Hi students, in this video lecture we discuss about the generation of single phase AC voltage. Now here this is a generator view. In a generator there are two main parts are there. The one is a stator. Here I am going to show this is a stator. This is a stator. And this one is a rotor. This is a rotor. So here stator means which is a stationary part. There is no movement here. For this part it is a stationary. It is fixed to a frame, and this is a rotor which is a rotating one. Now for generation of a voltage, that is a generation of an EMF, according to the Faraday's law of electromagnetic induction, um, whenever a magnetic flux linking a coil or conductor changes, an EMF is induced in that conductor. Now here the conductor coil is placed in the stator. These are the conductors. Here this conductor is a coil. This is actually how this coil is made means, here one conductor is passed through like this and taken from the back side, and it is a written path for this one. So here I am showing the conductor terminals as this is an A and this is an A dash. Clear? This is an A dash. Now in this coil the EMF is induced. Now that EMF we are going to taken from the stator terminal box. Okay, so that's why here in order to generate the EMF we need a magnetic flux. So this is a magnet. The magnet is placed in the rotor. A magnet has two poles. Now I am considering this as a north pole, and this is the south pole of the magnet. Now consider the rotor, that is a magnet, is rotating in a anti-clockwise direction like this. That is, the rotor will move like this. Now this magnet has a magnetic flux. That means that the magnetic flux will coming from the north pole like this, and in the south pole the magnetic flux are terminating like this. This pencil marks indicates the magnetic flux. When I rotate the rotor, this magnetic flux cuts this conductor. Is it right or not? So according to the Faraday's law of electromagnetic induction, EMF is induced in this conductor due to the north pole, and similarly when I rotate the rotor, as similar to our north pole, the south pole flux also cuts the A dash conductor. So that's why EMF is also induced in the A dash conductor. Now I will trace out what is the EMF values in a graphical form. So here I need to taken I need to draw a graphical picture how that EMF is generated. Now in order to trace out that EMF waveform, I need the x-axis as omega t. Okay, now here in this omega t, this is omega t, and in the y-axis I will taken the induced voltages. So that's why it is an induced EMF E. Now in this position, suppose I consider like this position, in this position, so I will taken this as a reference value, that is a 0 degrees. In this 0 degrees, what is the amount of EMF induced in the A? So there is a less amount of, not less, it is almost equal to 0. So there is no magnetic flux cuts this A conductor and A dash conductor. So that's why here the EMF value at this position omega t equal to 0. Here at this position EMF value is also 0. Now I taken that point, and when omega t equal to pi by 2, that is here, that is 90 degrees. In radians it is pi by 2. In radians it is pi by 2. In degrees it is 90 degrees. So when the omega t equal to pi by 2, it means that the rotor is at the position, the north pole is under the maximum flux linkages with the A conductor, and south pole have the magnetic flux linkages with A dash conductor. At that time the EMF induced, let it be considered as a positive. So that's why this is a maximum EMF position. Now if I continue the same rotation, that is when north pole comes here and south pole came here, if I rotate in the anti-clockwise direction, that means that if the rotor completes pi pi radians, at that time how much amount of magnetic flux linking this A and A dash, again it is 0 when north pole is here and south pole is here. So that's why here also 0 EMF. Now after completion of this, now if I still continue to rotate the rotor in the same anti-clockwise direction, now for another pi by 2 degrees, it means that totally 3 pi by 2 from here, 3 pi by 2. So what is the EMF induced? It means that it is a maximum amount. It means that north pole is here and south pole is here. So that's why a maximum negative. It means that it is just exactly opposite to your pi by 2. So that's why here it is 0. No, sorry, negative maximum. This is a negative maximum. Now if I still continues like this, and again one more pi by 2 degrees, it means that at this position, that is 2 pi, now again it comes to 0. It means that again this is the original position. Whatever be the situation here, the same situation comes here. So that's why for one rotation I am I am taking the values of induced EMF in this coil. So that's why if I trace out that one, it means that if I draw a graph, now it will looks like a sinusoidal waveform like this. If I still continue, now the same type of waveform will come here also like this. So this is a single phase EMF is there, a single sinusoidal waveform will come. So what do you mean phase means? Phase means a winding or coil. So that's why here how many coils are there? So only one coil is there, only one coil, only one coil. Here it is a A and this is your A dash. Now in order to denote in the form of a circuit point of view, we need to represent the same generator in the form of a circuit symbol of this AC generator is like this, like this. So that's why here A is there and A dash is there. So since it is producing a sinusoidal voltage, so that's why I need to represent like this. This is a circular symbol. Inside the circle, this is a sinusoidal. For this sinusoidal, at one instant it is, this terminal may be positive, at another instant this terminal is negative. So whatever be the value here, I am mentioning it as a RMS value. So how this RMS value will be there? So this is a maximum value, E maximum, E max, this is a plus E max, and this is a minus E max. So what is how the RMS value for this sinusoidal waveform? RMS value is equal to, that is E RMS is equal to E maximum by root 2. So that's why this is an ERMS value. ERMS value. Okay, so now here this is a single phase AC voltage. So all of you understood single phase means that phase means, what is the meaning for phase means? A winding or coil. Winding or coil. This is about the a single phase. Okay.